Today I am going to present about DC motor. First, what is motor? It is a machine which converts electrical energy into mechanical energy. Then first one is AC motor. Motor that runs on AC supply. Then what is DC motor? The motor runs on direct current. Next one is principle and operation of DC motor. When current carrying conductor is placed in a magnetic field, it experiences a force. That force is called mechanical force. Next one is construction of DC motor. Now you see the diagram of DC motor. That is a brushed DC motor. It shows the stator magnets, then windings, then brushes, then commutators, then terminals, then armatures. It is the important parts of the DC motor. Next one is construction of general DC motor. Most of the DC motor consists of these parts. First one is main field pole, then next one is main field coil, then next one is pole head, then interpole, then interpole coil, then air gap, then armature slot, then armature stack, then shaft, then armature winding, then yoke, then frame, then base. It is supported through the motor. These are the constructional and parts of the DC motor. Then DC motor main part is yoke. It is the outer cover of the motor, or otherwise called as frame. It provides protection to the rotating and other part of the machine from moisture and dust, etc. Then it is made up of iron body, which provides the path for the flux to complete the magnetic circuit. It provides the mechanical support for the poles. Poles means magnetic field coils. That is called the poles. It provides the mechanical support. Okay. Then material use. The yoke is made up of cast iron or silicon steel or rolled steel or cast steel, etc. Then second main part is pole and pole core. Poles are the electromagnet. Electromagnet means if the supply gives to the coil, it acts as a magnet. That is called the electromagnet. The field winding is wound over it. It produces the magnetic flux when the field winding is excited. The construction of the pole is done using the lamination of the particular shape to reduce the power loss due to eddy current. The next main part is pole shoe. It is an extended part of a pole. Due to its typical shape, it enlarges the area of the pole so that more flux can pass through the air gap to armature. Then pole core is made up of cast steel or cast iron. The next main part is field winding. The field winding means field coil wound around the pole. That coil is called field winding. The coil wound on the pole core are called field coils. The field coils are connected in series to form the field winding. The current is passed through the field winding in a specific direction so to magnetize the poles and pole shoes. Thus magnetic flux is produced in the air gap between the pole shoe and armature. Field winding is also called excitation winding or exciting winding. The material is used for making the field coil is copper. Due to the current flowing through the field winding, alternate north pole and south poles are produced. Normally in field coil, north poles and south poles are alternatingly fixed because of the current flow. The next main part is armature core. The armature core is seen in the diagram below. The armature core is a cylindrical drum mounted on the shaft. It is provided with large number of slots all over its periphery and it is parallel to the shaft axis. Armature conductors are placed in these slots. Armature core provides low reluctance path to the flux produced by the field winding. The material used for armature core is high permeability, low reluctance cast steel or cast iron material is used. Cast steel or cast iron material is highly permeability and low reluctance material is used. Then the armature core is laminated because to minimize the eddy current losses. The next main part is armature winding. The armature winding diagram is seen in the right side of top of the right side. The armature conductor is placed in a armature slots present on the periphery of armature core. Armature conductor are interconnected to form the armature winding. And the armature winding is rotated using a prime mover. It cuts the magnetic flux and voltage gets induced in it. The armature winding is connected to the external circuit through the commutator and the brushes. The external circuit means loaded. The load is most of the load is then bulb or fans, then motors. These are the loads. The material which is used to make the armature winding is copper because it is the good conductor material. The next important part is commutator. The commutator diagram is shown on the top of the right corner. Okay, it is a cylindrical drum mounted on the shaft along with the armature core. It is made up of large number of wedge-shaped segments of hard drawn copper. These segments are insulated from each other by thin layer of mica. The armature winding are tapped at various points and these tapping are successively connected to various segments of the commutator. Then next one is functions of commutator. It converts AC EMF generated internally into DC. It helps to produce unidirectional torque. The material used to make the commutator is copper and insulating material is mica. Next important part is brushes. The current are conducted from the armature to the external load by using the carbon brushes, which are held against the surface of the commutator by springs. The functions of the brush to collect current from the commutator and apply to the external load, and vice versa in the motor. The material used for making the brushes is carbon. It is rectangular in shape. The next one is back EMF. In the armature winding of DC motor, it starts rotating in the magnetic flux produced by the field winding. It cuts the lines of magnetic flux and induces the EMF in the armature winding. It is called back EMF. This induced EMF acts in the opposite direction to the armature supply voltage. This EMF is called back EMF. Then the back EMF formula is N pi ZP divided by 60 A volts. N means speed, pi means flux per pole, Z means number of conductors, P means number of poles, EB means back EMF, A means area of cross section of conductor. The next one is types of DC motor. First type is DC shunt motor, then second type is DC series motor, then the DC compound motor. Then DC compound motor are divided into two parts: short shunt compound, long shunt compound. In short shunt compound, the cumulative compound motor is there, then differential compound motor is there. Then long shunt compound motor, cumulative compound motor is there, and differential compound motor is there. Then the next important DC motor is DC shunt motor. And the DC shunt motor and DC series motor are the most common DC motor used in the world nowadays. In DC shunt motor, the armature and field winding are connected in the parallel across the supply voltage. The connection which has to be connected field winding and armature is connected in parallel. Okay, the resistance of the shunt field winding is always higher than the armature winding. So the shunt motor is also called constant flux motor. Then the next important motor is DC series motor. In this DC motor, armature and field windings are connected in series. It is shown in the diagram. The resistance of the series field winding is much smaller than the armature resistance RA. RA means armature resistance. Okay, RS means series field winding. The series field winding resistance is much smaller than the armature resistance. The flux produced is proportional to the field current. The field current increases means flux increases. The field current decreases means flux decreases. This DC motor is not a constant flux motor. Okay. And the applications of DC motor. These motors are used in applications where starting torque required is high and quick acceleration. That means conveyors, lifts. Mainly lift is used in schools, colleges, and industries. Then traction motors. Traction motors means it is used in the trains and all. Then hoists and lift crane. Then rolling mills. This is the applications of DC series motor. Okay, thank you.